Hello all, we have a Arduino Uno R4 board here, and then you can see here a LED is connected to the D6 pin of this Arduino Uno R4 board. And this LED, if you see here, positive is connected to the D6, and then there is a resistor here that is connected on the breadboard. You can see here this resistor is 220 ohms, and then there is a LED connected. The other end of the LED is connected to the ground. A very simple connection which should be known to all of us, right? Or for a beginner, this is how the connection is made. The resistor is actually required for current limiting. And if you see this particular LED is now actually PWM controlled. So what is PWM controlled? Basically, we are actually generating a PWM from here with starting from duty cycle of 0 to 100, and you can see the LED, okay, growing very brightly, off, again growing bright, going to low. Okay, so through PWM pin of this particular Arduino Uno R4, we are actually controlling. So now if you see, as we see from the board, the yellow wire, which is actually the PWM, is connected to the 6th pin on the Arduino Uno R4. Okay, so this is how the connection is made. Now let us look at the code. Hello all, this is a simple code which we see here for the PWM. Okay, and we have assigned the pin 6. We'll explain in the schematic why we considered pin 6. So if you see here, this is the schematic for Arduino Uno R4. Okay, so before going to the schematic, again we'll go one step further, and if you go to the data sheet of R4AM1, the pins GTIO C0A to GTIO C7A. Okay, these basically are the pins, the PWM pins from which we can generate the PWM output out of this R4AM1 controller. Okay, so now if you go to the schematic and if we see the schematic of this R4AM1 or Arduino Uno R4 schematic, which has R4AM1 controller, if you see D6, it is actually connected to P111GPT3A. Okay, now if you search for this particular pin, okay, you can see that it is connected to GTIO C3A. Okay, you can also connect it to GTIO 4A, you can also connect it to GTIO 2A, you can use, I mean, okay, but as this particular pin GTIO C3A is connected to P111GPT3A, okay, so this particular pin is used for generating the PWM. Now if we go back to the code, this actually is 3A. Okay, so the 6th pin. Now there might be a question like, can't I use GTIO C4A? Okay, yes, it can be used. You can also use 7A, but if the 7A is not connected to the Arduino compatible connector, you may not be able to write a code in Arduino. You might have to use the IDE which is to be used for NSS, and then write a code for NSS controller and try to use a PWM. Okay, as we are using the Arduino IDE for coding, okay, we actually have to use only the pins which are on this Arduino board, and that's why we used D6. Okay, now going back to the code, we have three variables here, PWM6. So PWM pin which is assigned 6 value, and then brightness is assigned 0, fade amount is assigned 5. Okay, we'll see what are these. And then we have set up the pin, PWM pin which is 6th pin to output. Okay, the pin mode is set to output. Till now here we haven't talked anything about the PWM. So to generate the PWM, we need to use a function called analog write. Okay, so this analog write is a inbuilt function in the Arduino. So Arduino write of pin, and then if you give brightness is 0. So this generates this outputs the PWM. Okay, and what we are doing is we are actually increasing the brightness by 5 every time, and um, we are checking the brightness value. If it is less than or equal to 0 or greater than or equal to 255, that means if the brightness value goes beyond 0 to 255, okay, we are actually trying to reduce the value. Like example, as we start incrementing, this might go up to 255. Okay, if it goes beyond 255, we have to start reducing the fade amount, because again, as we have shown in the video, the PWM is actually increasing the brightness of the LED up to certain extent, and again it's going almost to 0 by reducing slowly. So here we are actually initially incrementing, and once it reaches 255, we are actually making it negation by reducing. Okay, and then for every application of this particular brightness in analog write, we are actually applying a delay of 30 milliseconds. So this is how the code is written, a very simple code, right? So the only thing which we have to understand in this particular code is, or which is difficult to understand, is that mapping which we have to check in the data sheet and see in the schematic, and we have to understand that only Arduino connector pin compatible things can be written in the Arduino IDE. So these are some of the critical things which need to be understood while coding this. Hope we gave a glimpse of how the PWM can be generated out of Arduino Uno R4 using analog write function. We are basically using the default codes. Thank you.